Okay, so we're going to continue with this whole idea of factoring, and we're going to go back to the difference of two squares and squaring binomials. So what I'm talking about here is this, which is the difference, or I'm sorry, squaring binomial. So we're looking at these two things. So where we have this binomial and the whole thing is being squared. And then we're also going to look at the difference of two squares. Remember, where you have the exact same values, but different signs within those two binomials. So here we have three terms. I'm going to go ahead and rewrite this guy right here. Now, anytime you see that this is a perfect square, that could be to your benefit. So when we factor them like this, it's probably going to be our best bet to go to a box and an X puzzle, just because it's going to be hard to know for sure when it is a perfect square binomial. So I'm going to fill in my first and last terms. I need a product of 36 and a sum of negative 12. So factors of 36 would be a negative 6 and a negative 6 to give me that total of 12. So this would be a negative 6x and a negative 6x. So when I go to factor out my rows and columns, I see I have x minus 6 and then x minus 6. So then would be my two binomials, or just x minus 6 squared. So really the only difference here is how you write your final answer. Your final answer is going to be a binomial squared. Same thing here. We are going to draw a box in our X puzzle. I'm going to multiply 4 times 25, which is 100. And then I need a sum of 20. So my first and last terms would be 4x squared and then 25. So factors of 100 would be 1 and 100, 2 and 50, 4 and 20, no, sorry, 25, got a little, 5 and 20, 10 and 10, I guess, would be where we stop. So if I need a sum of 20, we're looking at 10 and 10. So we would have 10x here and 10x here. So greatest common factor would be 2x. And down here, it looks like a plus 5. Here too, 2x plus 5. So if you notice, it's like the square root of the first one and the square root of the last one, or first and last. So then we would be, we would have 2x plus 5 squared. All right, so here's one of those special cases that we have going on here. If you notice, we're missing that middle term. So we're going to create it. And if you remember, we would essentially cancel it out or have a value of 0. So when we look at this, we can go back to the drawing board here to create our box and our X puzzle. So we need a factor of, or factors of negative 9, but a sum of 0. So when I fill in my first and last terms, if you notice, if we need a sum of 0, that means the values have to be the same. So we're looking at 3 and 3, but one is positive, one is negative. So then this would be like a negative 3z and a negative, nope, not negative, sorry, a positive 3z. So then I can go to my box and factor out the greatest common factors. So when I do so, looks like this one would be a z and a plus 3. This one would be a z and a minus 3. So then when I write these out and multiply, so I have z squared plus 3z minus 3z minus 9. There's that 0z that I had up here. So these two would be my binomials. All right, here's another one. So we have 16z squared plus 0. Oh, z. It's not a z, it's an x finally. Let me rewrite that. So we have 16x squared plus 0x minus 81. So I go to my x puzzle and I draw my box. Product of negative 81 and a sum of 0. So those values are going to be the same. So that means it'd be 9 and 9 and a positive and a negative. So then I have 16x squared here and negative 81 here. So that means I'm going to have 9x here and a negative 9x here. So we know we're factoring out a 9 here and a 9 here. We'll go ahead and make this one the negative. So then this would be actually 4x and 4x, and this would be a plus 9. So let's see what happens here. So 4x minus 9 times 4x plus 9. So 16x squared plus 36x minus 36x minus 81. Notice I did not focus on this piece here because it has a value of 0, which is what we need. So here would be our final set of binomials. We have one more examples here. Here's one of each of those. So we're going to start with, well, let me change colors here. I'm going to do my X puzzle first here. So I need a product of 25 and a sum of negative 10. So the values are going to be the same, and they're both going to be negative because I need that sum to be negative. So when I set up my box, I have v squared plus 25. So then I have a negative 5v, negative 5v. Factoring out the greatest common factor, this would be v minus 5, v minus 5. V squared minus 5v plus 25. Here, this is that negative 10v, which is what we have here. So then this is good to go here. It's going to be kind of similar for this last one as before. Starting with my x puzzle, I have negative 225 and then 0x. So we have m squared and then negative 225. So 225, square root of 225, so it would be the same values times itself. Let's see. It would be 15m and 15m and one of each, right? One negative. Oh no. Yeah, one of each. So here we would have m plus 15, m minus 15. So let's see. Oops, I put 5, but you know I meant 15. And minus 15. So then m squared minus 15m plus 15m minus 225. There's my 0. So there we go.